Hey, this is Math 6, Unit 1, Lesson 6, called the area of parallelograms. So we're going to practice finding the area of parallelograms today. So the first activity here in 6.1, it asked you how many dots are in the image and how do you see them. So this is really a question just to kind of explore the idea today of talking about area and parallelograms and what do you notice, what do you see here. And so you might look at this a different way from a neighbor, and that's okay. And so you want to have a discussion about how many dots are in there without trying to count them all up. The idea is to see, what do you visually see? Do you see any groupings that you can put together to help you add them up a little faster and see what might be there? So for example, you might notice that there are 1, 2, 3, 4, 5, 6 in a row. Okay, so I have, what you might notice is I have a row of 1, a 6, another row of 6, another row of 6, and down here another row of 6. So just quickly, I notice that I have 4 rows of 6. So 4 times 6, there's at least 24 dots that are present right there. Alright, and then I have these 2 rows which seem to have 3 and 3. So I have 2 rows of 3, which is going to be a total of 6. So combined, I have 30 dots, is what I can see there. Not adding them up, just grouping things together to see what makes the most sense. You might have grouped them a different way. You could have decided to group them up this way, right? Let's say if I used a highlighter, I could have grouped them like a row of 6, a row of 6, and a row of 6, right? So that'd be a 3 times 6. And then I could have said, okay, well, that's 3 times 6, and over here I have 1, 2, 3 rows of 4. So the same kind of idea, I could say it's 3 rows of 6, and then 3 rows of 4, and I end up having the same idea, 18 and 12, which combine to make 30 dots total. Just a different way of looking at those arrays and what that might be. Okay, so let's move on then to the part of today's lesson, 6.2, talking more about parallelograms and finding the area of each parallelogram there. Okay, so in this first activity, you're going to be working in your groups, if you did in class, and you were assigned to do one of the parallelograms to find out what the area is and to talk about your reasoning, your rationale for why you think the area is what it is. So if you looked at letter choice A, you would notice that you had a base with a length of 10 and you had this height right here of 6. What we said before is if you take the base and you multiply it by the height, you end up with an area. Okay? And we can do that by recognizing that if I took this piece here and if I slid it over here after decomposing it and wrote it there, I'd end up with a rectangular shape that would have a base and a height. So that's how that works there. So in this case, I would say that I had a base of 10 and I had a height of 6, leaving me with an area of 60 square centimeters, something along those lines. In B, we've talked before that what we call the base doesn't have to be the one on the bottom. It's the long parallel side that is attached to the height of it with a 90-degree angle. So it's important to recognize that our base in this case is right here. It's the 15, and our height is the one that's right here at 8 centimeters. So our base in this case here is 15, and that's going to be times 8. 15 times 8 happens to be a huge 120 centimeters squared. So again, have to know what the base is. The base is the one that's connected to the height with that 90-degree angle or that perpendicular line right there. Same is true for C. We look at C, we have a base, which in this case is here. Notice the 90-degree angle is down here, but that's okay. We could draw it here as well. It's the same angle measurement right there. It's just how it's going to work out. So we have a base in this case of 9. Here's our base, and here's our height here. So 9 times 7 is going to be 63 square centimeters, or centimeters squared. And our last one, we have again a base of 1, 2, 3, 4, 5, 6, 7. So that's our base of 7 times a height, and we could draw a perpendicular line from there to there. And our height would be 1, 2, 3, 4, 5. So 7 times 5 is 35 centimeters squared. So different ways of going about solving them there. Just what do you see? But again, trying to find that base and that height for the first part of that question. The second question here wants us to refer back to this shape right there. So we'll come back to that in just a second. It says in parallel B of the first question, what is the corresponding height for a base that is 10 centimeters long? Okay, I'm just going to sketch it real quick for you, just so I don't flip back and forth. But B looked like this. You recall, it had 10 over there, and it said this length right here, which initially was the base, was 15, and it had a height right there, and that was 8. Alright, that's what B looked like. So the question though, initially we said that when we found the area the first time, we did 15 times 8 for an area of 120 centimeters squared. Now what it's asking is this: what is the corresponding height for the base that is 10 centimeters long? So now it wants to use this as the base. Can we do that? Well, the answer is yes, we could, but to do that I would need to find out the height, and that's what it's asking. Right? It's wanting to know what is the height if we're talking about a base of 10. Now, the shape isn't changing at all. Nope, it's the same shape completely, which means the area is going to stay the same. So I can actually write this out like this. I know the area is still going to be 120 centimeters squared. I know now that my base is going to be not 15 this time, because the new one is going to be 10. I don't know what that height is going to be. I can write an X there, or I can write an H for the height, for what this height is going to be. The height's going to come down here and be right there. I don't know what that's going to be. That's what I have to figure out. But really what I have left is I have this algebraic equation here that says 10 times some number is going to get you to 120. So what you're asking yourself is, what number can you multiply by 10 to get to 120? To solve that, we do that by dividing both sides by 10, dividing both sides by 10. So that becomes simply h over here, and 120 divided by 10 is 12. And we would say it's going to be 12 centimeters. So the height that this would end up being is 12 centimeters. Why? Because 10 times 12 equals 120 centimeters squared. So you're looking for that missing value that gives you the same area. And again, it's the same area. Why? Because it's the same shape. For number 3, it says two different parallelograms, P and Q, both have an area of 20 square units. Neither of the parallelograms are rectangles, so no rectangles. On the grid, draw two parallelograms that could be P and Q. Alright, so in order for that to work out, again, our base times our height has to equal 20. Why? Because we're looking for an area of 20 square units. So you want to just think about, and maybe do this with a partner, what two numbers can you multiply together to get to 20? Well, one that might come to mind is 5 times 4. 5 times 4 is 20. Another one that might come to mind is something like 10 times 2. And 10 times 2 is 20. So let's see if we can draw two parallelograms with those dimensions. I'll begin first of all with the one that has a base of 5. So I'll go 1, 2, 3, 4, and 5 right there. I know it's not going to be a rectangle, so I'm not just going to go up 4, 1, 2, 3, 4, although that's about where I'm going to be. But let's go up about, let's just pick a spot. Let's go over 2 units, and let's pick a spot here. And I can make this my height line. And that's my height line there. I could go out 5 more, 1, 2, 3, 4, 5, to have the parallel lines. And then we can play a little bit of connect the dot here, there, and there. So here I have a base of 5, sorry, and a height of 4 for an area of 20. I can do the same thing with a 10 by 20. I can make a base of 10. Let's start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could pick a spot, and again, pick wherever you want. I could pick it here if I wanted to, and go, let's make this my height of 2, because I'm going up 2 units. And I can, anywhere I want, really. I could start there, or I could start here. It doesn't make a big difference. Right? Doesn't make a big difference. I can start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then play connect the dots. So I have a base of 10 and a height of 2, give me a parallelogram with 20 square units. Alright, good stuff. Now let's take a look at the Are You Ready for More? This question's a little bit trickier here, but it's a great question to see if you're kind of getting the idea here. It says here's a parallelogram composed of smaller parallelograms, right? So we have little ones right here, like this. We have one, another one, another one, and another one. The shaded region is composed of 4 identical parallelograms. All lengths are in inches. What is the area of the unshaded parallelogram? So this one right here in the middle. Explain or show your reasoning. Okay, well, what we're going to want to do is figure out potentially what the area of the whole shape is going to be, and then find a way, to subtract to find out what's missing. So in this first parallelogram right here, I am given the dimensions of this length, which is 5, so that's a base, times a height of 2.4. Well, 5 times 2.4 is equal to 12. So we know that the area inside of each of these is equal to 12, right? This has an area of 12, an area of 12, an area of 12, and an area of 12, right? So that's okay there. Now notice they gave us this length right here. The reason they gave us this length is so that we could figure out, if we wanted to, what would be another height, okay? What would be a height? So a height right here, if I was to draw a line right there for this parallelogram and make a height, what would be this height? The reason I want to find that out is because it's going to help me figure out how tall this whole thing is. Because if you notice, if I was to continue this line right here, do you know how tall this piece is right there? Think about it. Is this the same as what's right there? Sure is. So that's a 2.4, right? So that's 2.4. Do I know the length of this entire base? Sure do. It's 8. So I know that I could find the area of the entire shaded parallelogram by doing 8 times the height, but I need to know that height there. So let's come back for a second. So to find this area, if I know the area here is 12, then I know that in this shape here, the base times the height equals 12. So what is that height going to be? What number times 3 gets you to 12? In our case here, we divide by 3, and so the height is equal to 4. So I know that this shape right here has a height of 4, this line, which means that my entire piece, right, I'm going to draw off to the side here real quick for you. This whole height is going to be 4 plus 2.4, that and that, so it has a whole height of 6.4. That's the whole height of the shaded parallelogram. So the area of the entire parallelogram, including the middle part, is 6.4 times 8. And 6.4 times 8 equals 51.2. So the whole shaded area, the shaded parallelogram, the whole thing is 51.2. I want to find out that part right there. Well, then let's take away all the little shaded, the small parallelograms. We know that those ones, they were each had a value of area of 12, and there were 4 of them, weren't there? 12, 12, 12, and 12. So 12 times 4 is 48. So let's subtract this. So that becomes 2, and we're left with 3.2. So if I take the whole thing and then subtract all the parts around, the 48, I'm left with just a little space in the inside, which is 3.2, in this case here, they're all inches, 3.2 inches squared. And that's the missing piece of that parallelogram. So kind of a fun little puzzle to figure out, but it takes some steps there to work and try to find the additional heights using this strategy here to see what's missing. Alright, so in summary, any pair of base and corresponding height can help us find the area of a parallelogram. but some base height pairs are more easy to identify than others. So we use the base and the height to find the area of a parallelogram. Right? So when a parallelogram is drawn on a grid and has horizontal sides like right here, we can use the horizontal side as a base. It's kind of nice. And then the vertical side we can do with that right there to find out what the height's going to be. Okay? It's kind of handy when they come on a grid line like this. It's nice and easy to see. I can count those out, no problem. But sometimes when it's not drawn on a grid, you can still find the area base and the height. You can find the area if the base and height are known. As long as they draw that out for you, the 8 there and the height there with that 90-degree angle, I can still figure out what that's going to be. In this parallelogram, the corresponding height for the side that is 10 units is not given, right? So while it could be a base, I don't have a height here to help me figure that out. I could work at it and figure it out with some extra math, but for now we'll leave it there. So regardless of the shape, parallelograms that have the same base and the same height have the same area. So if it's the same base, same height, it's going to be the same area, right? So we saw it before. This is 3 times 4, it's still 12. This is a 3 times 4, it's still 12. 3 times 4 is still 12, and 3 and 4 is still 12. So even though they look different, they actually have the same or cover the same amount of area there. All right, let's pause there and give a moment to do your homework, and then we'll come back together in just a moment. All right, homework time. Which of these 3 parallelograms have the same area as each other? Or which of these parallelograms, not 3. Which 3 of these have the same area? All right, so to solve that, what we're going to do is look at the bases. 1, 2, 3, 4, 5. In this case here, a height of 1, 2, 3. So we have a 3 by 5. And so 5 times 3 is equal to 15. Over here, right, we could find the height by going outside, down this way. We could extend the base and say that the base is 1, 2, 3. And the height is 1, 2, 3, 4, 5. So it has an area of 15 units squared. Over here, we have a base of 1, 2, 3, 4, and a height of 1, 2, 3, 4, for an area of 16. And over here, we can make this the base of 1, 2, 3, and we can make a height right there of 1, 2, 3, 4, 5. And again, 3 times 5 is 15. So which 3 are the same area? We would say A and B and D, because they all have an area of 15 units squared. Number 2, which of the following pairs of base and height produces the greatest area? All measurements are in centimeters. So looking at which one has the greatest area, which would be the largest number, right? So for A is going to be 3.5 times 4, right? That times that, so it becomes 2, 12, 13, 14, 1 decimal. We have 14 for this one, so A is at 14. For B, we have 20 times 0.8. 8 times 0 is 0. 8 times 2 is 16. Don't worry about that one there. We have 1 digit behind the decimal, so move the decimal sign there. So B is at 16. For C, we're at 2.25 times 6. 6 times 5 is 30. 6 times 2 is 12, plus 3 more is 15, so 15. And 6 times 2 is 12, plus 1 more is 13. We have 2 digits behind the decimal, so we'll go 1, 2 digits over there, and we'll put that right there like that. And so we have 13.5. And our last one, D, we have 10 times 1.4. Okay, 4 times 0 is 0, 4 times 1 is 4. Start with a 0 there. 1 times 0 is 0, 1 times 1 is 1. We have 140, 1 decimal, so we have 14 right there. All right, and that's all we have. So our largest one, our greatest area, is going to be B with an area of 16. All right, next one. Here are the areas of 3 parallelograms. Use them to find the missing labeled with a question mark on each parallelogram. Alright, so on my paper here, I have the older version here. A is 10, B 21, C 25. So I'm going to transfer that real quick. Okay, A is 10, B is 21, and C is 25. That's the area I'm aiming for. Alright, so how do we get there? We're going to do a base times the question mark, right? The question mark is going to give us an area of 10. So 5 times what number gets you to 10? Hopefully you're thinking 2. Alright, 5 times 2. If you're not sure, divide both sides by 5, and that's your solution there. For this next one, we have a base is the question mark times a height, which is 7. It's going to equal 21. Don't worry about that one right there. It doesn't really matter because that's the part we're talking about. So what number times 7 gets you to 21? That would be 3. And then over here, again, we have a base and we have a height. Does this number right here matter too much? Not really. Not too much. Why not? Well, because we know that our base times our height has to equal 25. Is that right? Our base times height has to equal 25. So, what's our base going to be? Well, we're going to say that we divide both sides by 5, and our base is equal to 5. Alright? This part right here really doesn't matter too much for us. We're not worried about that because we are just looking for what the base is going to be. It has to multiply by the height to get us where we want to go. Alright, number 4. The Dockland building The Dockland building in Hamburg, Germany is shaped like a parallelogram. Okay, so if the length of the building is 86, so if it has a length of 86, and its height, if we were to draw a line there, is 55, what is the area of the base of this building? So we would do an 86, the base, times the height, 55, to find the area. And in our case here, 86 times 55, we have 30. We have 43, have a 0 there. We have another 30, and we have another 43 there. So 3, 7, 4. We have 4,730 meters square, or square meters. Becomes the height of the area of the face of the building. And number 6, or 5, sorry, number 5. Okay, all the segments that could be the height of the side of the base, if the side M is the base. So if this is my base, which parts could be height? Well, I'm going to go ahead and extend this line all the way across, and the reason for that is as long as it comes down and it makes that 90-degree angle, it can be considered a height. This one clearly is going to be a height because it comes straight down, and there we go. So F is going to work. But in the same way, I could extend outside the parallelogram here, and E would work, and I could extend here, and J would work. No problem. And this one, even though it's extended even further away, is still going to be a valid height. So we would say E, we would say F, we would say J, and we would say K. And then finally the last one, find the area of the shaded region. All measurements are in centimeters, so let's take a look here. It's a great question. The next one. The area of the shaded region. Alright, couple ways of going about this, probably more than a couple actually. I could first find the area of the entire shape. Here we have a length of 14, and we combine the whole length together, and we have a height there of 10. So the entire shape is a 14 by 10 rectangle, which is 140 units squared. Alright, now I have these little triangle pieces. Notice the triangle, the little one here, is a 2, base of 2, height of 6, right? I also have one over here, which is a base of 2, height of 6. So if I take that base of 2, height of 6, and I join it with this base of 2, height of 6, we end up with another rectangle, which has an area of 12. Okay, and then I take a look over here, and I have this triangle, which has a base or height of 4 and a base of 12. And here I have a 12 and a 4. And so if I join those together, I end up with something like this: height of 4 and base of 12, which means it has an entire area of 48. Alright, so I want to find out the area of the shaded part, which means I need to take the whole thing and subtract the triangles from the outside, right? I want to get rid of these, get rid of these, get rid of these, get rid of these. So 14 and 48 together is going to add up to be 60. So the extra triangle space is 60. So if I subtract 60 from the whole area, I end up with 80. And so my answer is going to be 80 square units right there. And that's the way you might go about solving that one there. Okay? Another thing you might start to notice is you start recognizing that, gosh, this one right here is going to be a triangle, and when I put it together I get 12. A half of it would be 6. And so something you might start to notice is that, boy, if I cut these parallelograms or rectangles in half, I end up with triangles. And so there are other ways of looking at it, but we'll talk about that tomorrow. That's it, and have a great day.